Hi, welcome back to Mr. Slover's Math. Today we're going to focus on greatest common factor again, but this time we're focusing on greatest common factor of an expression. So our warm-up is getting us ready to get our mind ready for what we're doing today. So here's a review of what we did yesterday. We've got list your factors of 4, list your factors of 8, list your factors of 12 and 24, and find the greatest common factor. Then number 3, although it doesn't appear that it's related to what we're doing today, it actually is. We're actually going to start with this information, and we're going to work backwards and end up with this. Okay, so it is related, and that's what we're getting at today. So example 1 says factor the following expression. So I've got a bunch of red notes here, and let's make sure we take the time to read them. It says we're going to look for the largest factor from the factor chart, and we're going to divide each term by that greatest common factor, and then we're going to write what's left in the parentheses. So let's see this in action. 14x plus 24. My greatest common factor, or the largest factor, is 2. That goes on the outside of my parentheses. Now I'm going to take and divide each term by my greatest common factor. Just like it says here, divide by your largest factor, your greatest common factor. 14x divided by 2 is 7x. It's going inside the parentheses. 24 divided by 2 is 12. It's going inside the parentheses. I had a plus sign, I put a plus sign. So what I circled is my answer. What's on the outside is the greatest common factor. What's on the inside I get when I divide my original problem by the greatest common factor. So let's see another one. In letter B, my greatest common factor is 15. So 15 is on the outside of my parentheses, and then I divide each term by that greatest common factor. 15y divided by 15 is 1y, or just y. 30 divided by 15 is 2. So once again, what's on the outside is my greatest common factor. What's on the inside is what's left over after I divide. And then letter C, same idea. So you can try letter C on your own and then check your answer. Example 2, same concept, but now I'm adding in a greatest common factor that has more than just a number. It's going to have a number and a variable. So we're doing the same thing. Find the number, the greatest common factor number that goes into both of them. In this case, it's 5. And then I check my variables. They both have the letter x. Okay, so that means they do have a greatest common factor in regards to a variable. And yesterday I noted that you want to take out your lowest power. And that's what it says here, take out lowest power. So if I have x to the 5th and x squared is my lowest power. That goes on the outside because that's my greatest common factor. My greatest common factor is 5x squared. Just like in the previous problem, I'm going to divide my coefficient. 45 divided by 5 is 9. 5 divided by 5 is 1. I have a plus sign and a plus sign. So that part matches what we did on the last example. The new step says now that we need to subtract our powers because we took out an x squared. We took out a 5x squared. Right now we divided everything by 5 already. We didn't divide these by x squared. When you do that, you subtract your powers. So 5 minus 2 is 3. 2 minus 2 is 0. You may be thinking, well, Mr. Slover, why didn't you put the x there? No. What does 0 mean? 0 means nothing. I don't have anything. So if I don't have anything, I'm not going to put an x there. Okay. So make sure that you do that. If you take all of your letters away, I had x squared, I took out an x squared, I only had an x squared. I took them all away. I can't put that variable back in my answer. So letter B, same idea. Find my greatest common factor for the number, for the coefficient. In this case, it's 4. And then I take the lowest power, because they're both c's, I take the lowest power. So c to the 5th, c squared. C squared is my lowest power. So I divide each term by 4c squared. 12 divided by 4 is 3. 4 divided by 4 is 1. I have a minus sign. And now I look at my variables. C to the 5th divided by c squared. So 5 minus 2 gives me 3. 2 minus 2 gives me 0. So once again, if I have a variable and it has c squared divided by c squared, and I do 2 minus 2 to subtract my powers and I get 0, don't have any c's left. I'm not writing that in my answer. Example 3 is just the same idea, so you can go ahead and work through those as you need to. Now notice on letter D, the only thing I can take out is a 2. You maybe think, well, Mr. Slover, they have letters. I agree, but those letters are not the same. One is a B, one is a Y. Those are not the same letters. If they were the same, we could take them out, but they're not. And then the very last one, example 4, it says factor the following expressions. 4x minus 3. Well, if I list my factors of 4 and my factors of 3, the only thing they have in common is the number 1. I don't have any letters in common. I don't have any variables in common. This has an x and this does not. So since 1 is the only number they have in common, if 1 is my greatest common factor, that means it's prime. There's nothing I can do. I can't factor anything out. If I factor out a 1, it doesn't change the problem. So same thing on B and C. I can't factor anything out other than 1, so I'm going to write prime. Okay. So to recap, you are looking for your greatest common factor, and then you are going to divide each term by your greatest common factor. And if you need to, if you have variables, then you subtract those